Elliott. This is the second part of a series on structural relations, and today we'll be introducing some terminology to do with syntactic structure, including nodes, branching, and dominance. The first thing that we need to get out of the way is just the sort of basic parts of a tree. And if we look at this diagram here, we can see two things that jump out at us, right? There's the letters, like A and B, and there are the lines that connect them, like this one right here. And we call these lines branches. Trees in the real world have branches, and trees in syntax do as well. So lines are just paths that connect two parts of a tree, and the two parts that lines connect we call nodes. So nodes are either end of a branch. So A and B are nodes because they're either end of this branch right here. If we just want to get a little bit of quick practice with these notions, we might ask ourselves, well, how many branches are there on the tree? And how many nodes are there? And you can pause the video and do this yourself if you want some practice, but I'll just tell you the answers are 7 and 8. So now that we've introduced these notions of nodes and branches, we can ask ourselves, how do nodes relate to each other on the tree? And one sort of basic relation that one node can have to another is dominance. And so I'll read this sort of technical definition, I'll go over what it means, and then I'll go over a few examples. So a node x, and x and y in this definition are just variables, like in algebra, things that we can substitute in any part of a tree into this definition and see if it ends up working out. So a node x dominates another node y if and only if x is above y on the tree and a line can be drawn down from x to y. So there are two parts of this definition. The first is that, and I'll underline it here, x has to be above y. And by above, we don't mean the sort of spatial sense of above, right? In terms of our drawing, right? I mean, we could draw the tree differently, and it might be that G is actually above B because we extended this branch all the way down here and drew B right there. That's not what we mean when we talk about one node being above another node in a syntax tree. We mean above in terms of how many levels of structure are between it and another node. So for example, to get to B on this tree, we only need to go down one branch from the top, right? Another way of thinking about that would be there's only one phrase structure rule or bracketing operation that we need to do to get from sort of the big sentence down to this node right here. But this node D, right, there are two operations that we need to do. There's the branch from A to B and then also the one from B to D, right? So D is sort of two levels of structure down, whereas A is only one level of structure down. And so B is above D on the tree. It's also above E and F, just as E and F are above G and H. And I think it's a helpful practice to have your sort of structural levels of depth correspond to the spatial levels of depth as we have in this tree here. So if you just draw things that both come down from the same node, so that are connected by these same branches, if you do draw them on the same level, like we have here. So that's one part of our definition. What's the other one? So the second part of our definition is that a line can be drawn down from x to y on the tree. And I'll especially emphasize this down because that's very important for dominance. You can think dominance down when we're drawing our lines. So to draw a line, right, we're going to kind of traverse through a series of branches from top to bottom. And this is a separate notion of being above or below, right, because we can draw a line straight down from B to D, and B is above D on the tree, but even though B is also above E, there's no way we can draw a line straight down from B to E, right? There's no branch here in actuality, right? We just kind of cheated and drew it in, right? We would have to if we were gonna connect from B to E just using branches, sort of have to go up here and then down here, right? But that's not what we're interested in, right? It has to be straight down. So when we put those two parts together, our two parts of dominance, we get this definition, right? That one node dominates another if it is above that node on the tree, and there's also a path that we can draw straight down from the dominating node to the node that it dominates. So to give you a few examples, um, we can think about what A dominates. Well, A really dominates everything, right? Because first, A is above everything, right? It's the first level of structure. There's nothing less deep than A. Everything sort of has to have rules applied, has to have branches down to get to it. So A is above everything. And we can also draw a path straight down from A to every other node on the tree. So taking A, B, and D, A, C, E, G, A, C, F, H, right? We can draw nodes straight down from A to every other node. It's above every other node, so A dominates every other node on the tree. And I actually have a typo here. A does dominate C. I didn't catch that, so we can add a little C in right there. But A dominates all the other nodes. If we look at D, right, and we kind of already hinted about this when we were talking about our definition, well, what is B above? Well, B is above a lot of things, but the only thing that we can draw a straight line down from it to is D, right? We can draw a line straight down from B to D, and it's the only branch coming off of B, so we know that B dominates just D right here. With these notions of dominance, we can also say some interesting things about particular nodes on the tree. So a root node is a node that nothing else dominates. So A is going to be a root node. And a terminal node is a node which does not dominate any other node. So if we want to cast about for an example here, D would be a terminal node, right? There's no branches coming under it for things that it might dominate. So now I have a few exercises for you to do where we fill in the domination relationships for the rest of the tree. And I invite you to pause the video and try and figure these things out for yourself, and then I'll come back and explain what the answers are. Okay. So we have A and B filled in already, but let's take a look at C. And we have our definitions of all these things down here. So I'll draw in our levels of structure. So C is above D, E, F, G, and H on the tree, but the only things that we can draw a line straight down from it to are E, F, G, and H. So we can say that C dominates E, F. It's a little awkward writing on my computer here, but hopefully you can understand it. C dominates E, F, G, and H. For our next node, D, we already gave the example that D is a terminal node, right? It doesn't dominate anything else. Because it is above G and H on the tree, that's true, but we can't draw a line down from it to anything else, right? There's no branch coming off of D right there. So we say D, there's nothing that it dominates. We'll just draw a line right there. Well, how about E? Well, E is above G and H, but the only thing we can draw a line straight down to is G. And let's maybe switch to another color so we can see these things better, right? We can draw a line from E to G. So we'll say that E dominates G on the tree. It's sort of a similar situation with F, right? F, we can draw a straight line down to H. So even though F is also above G, there's no straight line that we can draw. So we'll say F dominates H and nothing else on this tree. And finally, G and H themselves, much like D, there's no sort of branches coming down from them, right? We don't have anything underneath them. So there is nothing that G and H dominate. And finally, we already answered this kind of by doing this first exercise, but what are the root nodes of this tree? Well, if we want to see what a node, which node the node dominates is, we can see what's listed here. And the only node that's not listed here is A. So A is our root node. It's at the top of the tree. And which are our, oh, I'm sorry, not head nodes, but terminal nodes. Although, in fact, all the terminal nodes in our trees will be heads. I apologize for that mistake. Terminal, if you can read that. The terminal nodes at the very end of the tree are going to be D, G, and H, right? If we look here, there's nothing that they dominate. Okay, so that's what we have for today. We learned dominance, root node, and terminal node. In the next video, we'll talk about some other notions that we can derive from these more basic ones. Thanks for watching.